So our slope-intercept form, which is f of x equals mx plus b, or it could also be f of x equals b plus mx. Both of those are linear functions. Key thing is, so we should have our input variable in there, and the number that's multiplying with our variable is our value for m, or our slope, and then the constant that's adding or subtracting on the outside, that's our y-intercept, b. So b is our y-intercept, and this is where the graph crosses the y-axis. So where the graph crosses the x-axis. You could also think of it as where x equals 0. So like we did in that last video, plugging in x equals 0. But basically we have this coordinate 0, b that we can graph. Now our slope, which we use the letter m to denote, is the change in output over change in input. Over change in input. And there are many different ways that we can write this. We could think of it as change in y over change in x. Something I'd like to note here is in terms of graphing and thinking of using our slope. So the change in y, so that's how we move up and down. It's our vertical axis. So this is how we move up or down. If that change in y is positive, that's this upward direction, and if it's negative, we're moving downward. And then this change in x is how we moved horizontally. So it's our horizontal axis, so moving right and left. And if that change is positive, it's representing a change to the, or movement to the right. If it's negative, movement to the left. What we looked at before that I want to bring through with our function notation is slope relates to that average rate of change. So another way of writing it, just using our function notation, difference in outputs over difference in inputs, where we're looking from this interval a to b. Okay, so y-intercept, slope, let's put this together in terms of making our graphs and reading our functions and knowing what it's telling us in terms of our function notation. All right, so we have this function 5 minus 2/3 x, and we want to graph this by using the slope and intercept. So my recommendation is start with the y-intercept, because that's going to give us a coordinate to start at. So with this, that constant is a positive 5, so our y-intercept is going to be this coordinate 0, 5. So we can go ahead and plot 1 point. Now we need a second coordinate, and what we want to use is the slope to get that second coordinate. So our slope is this negative 2/3, and if it's helpful, you can think of negative 2/3 a few different ways. Negative 2/3 is the same thing as negative 2/3, which is the same thing as 2 over negative 3. Basically, we want that negative either in the numerator or in the denominator. Doesn't matter which one, we'll get to the same answer in the end. So m equals, I'm just going to put in the numerator, so negative 2/3. And like I was saying, this is telling us how we're moving up and down and right and left. So having a negative 2 in the numerator, because it's negative, this would be telling me to go down 2 units. And then the 3 in the denominator, it's positive, so that would be telling me to move to the right and right 3 units. So this is telling me to go down 2, right 3. So it's giving me a map to a second coordinate. So what I want to do is go to this 0, 5. I'm going to go down 2, right 3, and that's having me land at 3, 3, and that would be my second coordinate. And then we could keep following that trend, down 2, right 3. You can reverse it, left 3, up 2, but with that you could get some extra coordinates out of there. And then we just connect them with our line, and that would be it. So that's how we can use the y-intercept and slope to make a graph. Start with your y-intercept and then follow the slope to a second coordinate. All right, let's talk about matching. We have these 4 different linear functions on a graph here. Let's not even look at the functions yet, but with these 4 graphs, some things I could notice is maybe my eyes are drawn first to these parallel lines. So lines that are parallel are going to have the same slope. Let me make a note of that. Parallel lines have the same slope. So if I look at those 2 equations, we're going to have the same value for m for those 2 functions. Now what differs between them are the y-intercepts. So we can see actually 3 of these graphs have a y-intercept at 0, 3. So how that should be coming through is a value for b for 3 of these. And then this one line that's parallel has a different y-intercept, which is happening at 0, -3. So that's going to be a value for b. In fact, since that's the only one with a y-intercept of -3. So let's go to our functions and see. So f of x equals 2x plus 3. So that's going to have m equals +2, b equals +3. G of x equals 2x minus 3. So that's a slope of 2. Intercept of -3. So I think that one's going to be g of x. So that one line that's parallel but has a y-intercept at -3, that's going to be g of x. All right. H of x is a -2x plus 3, so this has a -2 slope, and then a y-intercept of +3. K of x is 1/2 x plus 3, so this has a slope of 1/2 x, and then +3. So we found g of x. In fact, let me just kind of get that out of the way. So we have f of x and h of x and k of x left. Let's go ahead and look for h of x because that has a negative slope. So it should be the only graph that's decreasing. And what we can see is right here. So it's going through that 0, +3, but it has a decreasing trend. That's going to be h of x. So that one's taken care of. Now we have this difference of a slope of 2 versus a slope of 1/2. Well, when we found g of x, that had a slope of +2. So that tells me that the line that's parallel to it also has a slope of +2. So that's going to make f of x, this function right here. And then what's happening with k of x is that it's also going through that point 0, 3. It's not as steep as the other functions. It's kind of flatter. And that's coming from this value of 1/2. As the slope is closer to 0, the flatter it's going to be. Because a perfectly horizontal line has a slope of 0. So if it's just a little tilted, it's going to be close to 0, but either in a positive or negative direction. And then the steeper that it gets, the further from 0 that it's going. So that's going to leave this kind of flatter line is going to be k of x.